My name is Molavi. I'm doing my research under the framework of María de Maeztu. The title of my research is Control System Design for PEM Fuel Cell to Maximize the Efficiency and Minimize the Degradation in an Automotive Application. Okay, so in a fuel cell hybrid vehicles, there are many components, main components. As you see, the motor, the drive and battery, the fuel cell stack, the subsystem that's provide the hydrogen, and the subsystem that's provide the oxygen. So the main focus of my research is the fuel cell stack that's provide the electricity for the fuel cell hybrid vehicles. Okay, so the fuel cell stack actually is made of many cells that stick together to provide the requested power by the load. The working principle is shown in this figure. The hydrogen from one side, the oxygen from the other side come inside. Due to chemical reactions, electricity, water and heat is generated. The electricity is used to drive the car, and the heat and the water needs to be removed from the stack and controlled. So the fuel cell stack itself cannot be applicable in a real system. It needs some subsystems such as a anode subsystem that's provide hydrogen, the thermal subsystem that's provide cooling water, and the cathode subsystem that provide oxygen for the stack. So this stack and the subsystem, to be able to use it in a real car and have a mass product of this type of car, fuel cell based car, we have three main challenges: durability, reliability, and cost. So and that needs to be discussed and considered. Okay, this block diagram shows the integration of fuel cell stack and its subsystem with the other component in a fuel cell hybrid vehicles, which are the vehicle control units, the mechanical part, the battery and DC-DC converter, diagnosis system, and the fuel cell supervisory controller. My research is focusing on design this part, the fuel cell supervisory controller, which include three main parts: optimal set point generator, state machine, and power limit calculator. The optimal set point generator, the responsible is to find the optimal operating conditions for dynamic requested power. The state machine is responsible to coordinate and management the PEM fuel cell system process and implements the condition required to transit from one state to other states and do a communication between different subsystems. The power limit calculator is responsible for compute the available stack power information and deliver it to energy management system to be able to divide the requested power between the battery and the fuel cell stack, and compute the DC-DC converter current set points as a set point for the DC-DC. The other purpose of my research is to implement this supervisory controller in a real prototype car, which is in the Imbalance project, which is a consortium between some companies and University Politecnica de Catalonia. Thank you very much.